Today, myself, Mui, and Sarah are going to be talking about data diagnostics and what it is. One of the great things, and I think this can be said for many of the tutorials we're going to walk through over this SOS challenge. But one of the great things is what we're going to build here together is going to go beyond this challenge. This is going to be a resource that will be available to all of us and will really impact the way we are doing network studies. So I'm really excited to kick it off with SOS, but see how it continues to grow this year and the years to come. All right, so I like to start off with what I call a KUD. I think if there's any teachers in the crowd, you've probably seen this before. But what I want you guys to know walking away today is what is database diagnostics? I want you to understand how to create a profile for a given database, and we'll go through what that is. I want you to understand how to fill out the data diagnostics inputs. And then we're also going to interpret the data diagnostics output for at least one SOS example. I think we actually have all four prepared for you today. So our agenda, we're going to go over data diagnostics. We're going to build a database profile. We're going to go through our study question inputs. We're going to show the inputs for our 4 study questions. And then we're going to go through the output. So I'm going to take you through the elements of the study question you need to know to run data diagnostics, and then I'm going to hand it to Mui and Sarah, and they're going to go through the 4 study questions and then the output that we've already been able to generate. So what is data diagnostics? We've been talking about this a lot, and I've been throwing this term out a lot. But what it is, it's a very lightweight, simple R package that allows us to determine which databases have the elements required to answer a research question using only a set of aggregated summary statistics. And that bottom piece is really key because what we're going to be asking you to do is send to the Odyssey Coordinating Center the set of aggregated summary statistics, because then we can determine just from that set of statistics which databases have the elements required to answer a research question. So it takes out that initial, sometimes difficult piece of a network research study of just figuring out if your database is answering. So we're trying to take that whole piece out of it so that we can immediately jump in to a study and you don't have to go through that difficult, sometimes time-consuming part where you eventually find out, oh, my database doesn't even fit what we're trying to do here. And so this is really going to be really beneficial for the network and for us as a community. So going through this process, this is how it works. You see over on the left-hand side, hopefully you can see my pointer here. We start out with your databases behind your own firewalls. You then run what we're calling a database profile. So each database will have a profile generated. And these profiles consist of aggregated summary statistics like I was talking about. So you've got your number of persons, number of people by their sex at birth, persons by their year of birth, that sort of thing. So we have these aggregated summary statistics about each database. These then get sent to our central coordinating center where we have one table full of the metadata for every database in our network. From that, we can run database diagnostics just on this set of summary statistics. Using the input you give for a particular study question, data diagnostics will then output for you information about every single database in the network and whether or not each of those databases is appropriate to answer your particular study question. And it doesn't have to be one. I think for all 4 of our studies that we're going to be doing through the SOS challenge, I think we had a total of 14 different analytical variants. And I was actually able to run all 14 at one time through this process and get one output that shows for every single one of those 14 analytic variants, which databases would actually be appropriate. So just really quickly, I want to go through with you the summary statistics we are going to be pulling as part of this database profile. So what I really want to stress here is that we want counts of persons, persons by gender, year of birth, et cetera, et cetera. You can see them listed here. And please jump in if anybody has any questions. I'm happy to answer. And then we also do counts by domain. So you can see we're doing row counts by condition concept ID, for example. And we're also looking at the source concept IDs. And what I really want to stress here is that these are all independent statistics. So we're not looking at the intersection of any of these. We're just saying, how many people do you have by their year of birth? How many people do you have based on a certain condition concept? And later on, as we get into it, and we'll do some more examples, perhaps your study question says, I want people age 5 to 10 who have taken risankizumab, which is one of our drugs we're actually interested in for one of our studies. So looking at this, what these statistics can tell you is, do you have people age 5 to 10? Do you have risankizumab? That's all we're asking. We're not looking at that intersection. So that's really where the phenotype development and evaluation would come in, would be to say, do we see people that are age 5 to 10 with that drug? What this is saying is, do you have each of those individual pieces where I could potentially observe someone who is age 5 to 10 with that particular drug exposure? So we're just trying to understand, do you have those individual pieces of a study? Then we'll put them all together later on. And by doing it this way, we can really get to the heart of understanding which databases are fit for use for each individual study question. And again, helping us to understand our network much better, but also reducing a lot of that overhead that sometimes come with network studies. All right, so let's build a database profile together. All right. Have it up here. So I'm not going to run it straight for it. I just ran it recently, so I do have it available. But I want to go through with you is really how easy it is to run. So I have my RStudio session open, and I've installed the Odyssey package DB Diagnostics, and you can do it using this call to the remote library here. I then set up my connection details. So I have a local Postgres instance running a synthetic data set for purposes of this example. Now, what this is going to do, this is actually going to go and look at, if you guys are familiar with the Achilles package, it's actually going to go and look to see if you have any of these aggregated summary statistics already calculated in your results database schema. So what you would do is set where your CDM data live and what schema they live. You would then want to set where are your results information. So if you already have some of these aggregated summary statistics in a results schema, and you might have done this, many people actually use the data sources tab in Atlas. These are the same summary statistics that are utilized there as well. So you would put your results schema. You would also want to list a writable schema. So I know many of us in the community, we have different arms that touch different pieces of your database. So some people might have write access to where these results live. Some people might not. So you'd want to create a schema where you have write access, so that what happens is, if there are any missing analyses that this package needs, any other statistics that it can't find, it will generate those statistics and then write them to the schema where you have access. You also want to set your vocabulary database schema because it is actually going to go pull a couple things from the vocabulary. One of the things that we'll pull is actually the version of the vocabulary that you are using. We want to use this as an opportunity to understand what versions of the vocabulary people are using across the network. And there's some additional vocabulary work that it does to look at visits in your database. You then want to give it a name. So I've given this Cynthia V54 Odyssey example. You want to give it your output folder where the results should be written. The version of the CDM you're running, you want to set it as so without the V. And then this is actually really important. So you want to set whether or not you're going to be appending your Achilles results. So like I mentioned up here, if there are any statistics that it's missing, it's going to try to run those and write them to this particular schema. If you tell it you want to append Achilles, it's going to try to take those missing statistics and append them to the existing table. Otherwise, if you set it to false, it's just going to create a new table. Typically, I set this to false, but it depends on your particular setup. And if you guys have questions individually, we can certainly go over that in the office hours on Thursday. There's an option to round your values. So one of the things we heard from the community as we've been putting this together are ways we can make sure that we are, either masking any data that you don't want to share, or we want to make sure that we're not sharing any data that would be particularly sensitive. So to that end, you can choose whether you want to round your numbers to the tens or hundreds place. There's also a min cell count. It is set to 5, so anything under 5 will not be reported, and that is the default here. And then you can also set a list of concepts you do not want to report back. So we've heard from some hospital systems that they don't want to report never events. There are some that cannot report anything related to HIV infections or suicidality codes. So that is an option here, so you can exclude those if necessary. And then you can also run the DQD if you would like. I've currently set this to false, but that is your choice if you would like to run that. And then all you would do is just call this execute DB profile function. This one on mine, it really didn't take a ton of time. I don't know, I think Mui, your team ran this, and then if Philip is on the call, he ran it. I don't know if you guys, do you guys share how
it took about 20 minutes for
along
us to run it.
You to run?
Sorry, it took us about 20 minutes to run it per database, and I think we ran it on 5. And if you look at the number of patients we had, they were about, what, 8 million or so on average. So 8 million patients, 20 minutes.
Yeah, perfect. Yeah, so not terribly long, and it will depend on how many of those summary statistics you already have available. All right, so when you run it, what will come out is, so you see here in my output here, I've got this example. And what it's going to do is actually going to look at your release date. So it's going to look in your CDM source table for your release date and create a folder. You'll also notice that there's this metadata CSV file here. So what I wanted to do, and what we talked about in our meetings, was we want to make sure we are adequately identifying your database. So the first time you run database profile, it will actually give you a short set of pop-ups. I want to say it's anywhere from like 8 to 10. I don't think Maxime is here, but he wasn't too thrilled with the pop-ups. And then he ran it and he was like, hey, the pop-ups really aren't that bad. Like I'm not as opposed to them. And so what the pop-ups are going to ask you is things like, what type of data do you have in your database? Very importantly, what is the site name of the site that either owns or licenses the data? And who is the person that should be contacted in the event that your database is deemed fit for use for some sort of network study? Because of course, like I was saying, This will go beyond the SOS challenge. So we want to make sure we have your information there. So maybe someone is writing a grant proposal and they find that your database would work for their study. And so they want to contact you and say, hey, do you want to get in on this grant with us? It could be that, like for Mui's example, they are going to be selling licenses to their data. So perhaps someone runs in and says, oh, this IQVIA Italy data would be really helpful for me. They then know to contact Mui or someone at IQVIA to make sure that they can start to figure out how can we get access to this data. So I think there's a lot of different opportunities here, and we want to make sure we have your contact information correct, so that we can contact you in the event that your database has been identified as a good candidate for a study. All right, so if you go into here, you'll see that there's this zip file. This zip file is what you would share with the Odyssey Coordinating Center. And if I open it up just really quickly, I'll show you what's in there. So what this zip file is going to contain is 4 files. These 2 here, the profile results and the results distributed, these are the actual summary statistics for your database. The distributed is really just, these are actual distributed values based on measurement concept IDs. So there's 2 different ones here, but these are both the aggregate summary statistics that we are including. We are also going to be grabbing your CDM source information. So this is that source table, and if you've run the DQD, you already have this filled out. It should be good practice for everyone, but this is just that source information where it lists the CDM release date, the native data release date, your vocabulary version, that sort of thing. So we want to keep track of that as well. And then it's also going to include the metadata information like I was saying before. So it's those 4 files. You zip it all up. It's already provided to you here. And then you would share it with the Odyssey Coordinating Center. And that's where, if we come back here, that's where it would go into this network metadata table. So we're going to be compiling all of these together. And we've actually already done this. We had, like I said, we had some beta testers. Mui's team did a great job. We have a couple databases from Janssen, and we have a database from Serbia that Philip was able to run. And so we're already building out this network, and you'll see as we go through, you'll see the results from all of those databases we already have. So if you want to be included, we absolutely would love to have you. So please start thinking about running database profile and sharing it with us so that we can include your data in the Odyssey network. All right, any questions on that before we move on to the data diagnostic portion?
Claire, there's a question in the chat specifically for you about where can everybody find the script to run this?
Yeah, so that is a great question. I should have put it in the slide. So if you go to github.odyssey, no, let me put it in the chat, but it'd be github.odyssey.io/dbdiagnostics. So
it's in the chat.
Okay.
Adam put it above.
Perfect, thank you. Yeah, I don't have 2 screens today, so otherwise I would have put it in the chat. Thank you. Yeah, so on the GitHub IO page for DB Diagnostics, we have built out documentation for how to run the database profile, including the code that I shared just now. There's also code for how to run DB Diagnostics, because you don't necessarily just have to run it as part of the Odyssey Coordinating Center. You can also run this on your own network or your own database just locally. So there are multiple options for you there. And as you guys go through, we try to work really hard to get the documentation to a place that they are user-friendly and understandable. But please, if there's something that doesn't make sense or you are struggling with, please definitely put an issue or just contact us, because we want to make sure that it is easy out of the box and you guys aren't running into any issues.
We have a question from Nicole.
Mm-hmm.
Hey, Claire. Yeah, so we're getting ready to start a pilot. We're just starting to get our EHR data, and we're planning to just start with literally a single site. And I'm just wondering, can we still do these kind of checks with just one site, or only can you just do the data based profile and that's it?
So yeah, you could definitely do it with one site. It's really the database profile is just would run on that one site. And then when you run your data diagnostic, it would just return whether that one site would meet the study criteria or not. So that's not a problem.
Great. Thank you.
Yeah, great question.
No other questions right now.
Awesome. All right, so let's go through. So now, just as a reminder, we've run our database profiles. We have a set, I think currently we have, I want to say like 10 to 13. I'm like missing it off the top of my head, but I want to say like between 10 and 13 databases actually in our Odyssey network profile. So our Odyssey, I have it up on an Odyssey server. We've got this table with profiles for at least 10 different databases. So now what we're going to do is we're going to start to build out our data diagnostic inputs. So these are those inputs that would allow us to figure out which databases can answer which particular study. Now, the great thing about this is now that we have these profiles, we can run as many data diagnostic questions as we want. There is no limit to the imagination. We can try to figure out as many different studies as we can run, and then it all runs off of that same data profile information. So that's what I was saying, like, we're going to set this up for SOS, but we're setting a precedent moving forward that I think is really, really exciting for the network. And I think it's going to open up many more opportunities for us moving forward. All right, so let me see here. Let's go into the study inputs, and I'm going to hand it over to Mui. So here's the things you will need to know about your study to set up your data diagnostics inputs. You don't have to fill out every single one, but these are all the available options. And again, as you get the output and you start to look through it, these things are going to be independent statistics, but there is a way that we are going to try to just broadly estimate the number of people you would find that meet all of these criteria in a database. So we're just estimating, but these are still independent values. So you can set an age range, what genders or the assigned sex at birth you are interested in, what races and ethnicities you're interested in, calendar time. So you could set a particular age range. I know for one of our studies in the SOS challenge, we're doing that. The longitudinal follow-up. So how much time does a person need to be in a database, or how much time do they need in their observation period to be included in a study? I think for all of our challenges here, we're looking at least a year look back. And then you can pass in different concepts for your target, comparator, indication, and outcome. Now, you don't need to pass all of these. The only one that's required is going to be your target. So say you want to do a characterization of a rare disease, you may just want to pass in a concept list of just those concepts for that rare disease, and you can see which databases in our network actually have records of that condition. So you do not need to do all 4 of these, but they are there so you can figure out, all these different combinations you might be interested in. And then we've got domain requirements. And the way we look at this, we have required domains and desired domains. So required domains would be this category all, meaning all persons in your study need to have at least one record in a particular domain. So what I mean by that is, say, for example, I think almost all of our SOS challenge studies, we are looking at people with a certain condition who have been exposed to a drug. So in that case, we know that all people in our study need to have at least one condition and one drug record to be included at all. So that's what that means, this all means, and you'll see it as required domains as you set up that R code. Now the any is referring to, typically it's going to be referring to the outcome. So not everyone in your study needs to have, say, a record of a procedure, but at least some people do, because if the outcome is a procedure, then we need to make sure we're actually observing procedures in a database to actually run that study. So not every person in the study needs to have a procedure, but at least some do, so that we can make sure we can observe that outcome. Same thing with visits. Typically what you'll see, and you'll see it as Mui goes through the inputs for our studies. One of our studies is looking at inpatient stays. So it's defined on the outcome, if I'm remembering correctly. So we would say, well, not everyone needs to have a record of an inpatient stay, but at least some people do, meaning we need to be able to observe inpatient records in a database for us to be able to use it to identify the outcome. So it'll make a little bit more sense as we go through the required and desired domains. If you guys have additional questions, we can definitely go through that here and at office hours as well. All right, so I'm going to hand it over to Mui. Mui, do you want me to keep driving the slides here?
I'm actually going to hand it over to Sarah.
Fantastic.
Ah, excellent. Yeah, if you could drive the slides, I think it'd be great.
Sure.
Okay, so yeah, so as Claire showed it, she gave you an idea of the sorts of information that you're going to need to put in and consider. So taking a first look at the first study, you can see that we're already going to start putting in some age parameters. So we're looking at a minimum age of 18 with no sort of upper limits. We are going to be looking at the genders male females. And then you will see that there are some nulls in here as well. So really, this means that you're not going to be applying any sort of restrictions to the likes of, for example, race and ethnicity. You've got your longitudinal follow-ups of your year, your 365 days. And then you've also got your concepts listed below. So you've got the target concept that is in there. I won't attempt to obliterate the pronunciation of that one. I will probably do that with most of them. You have the comparator drug as well, and then obviously you've got your indication of the blinding disease and your overall outcome, which is the ESRD. So this is kind of what your considerations are going to be for this particular study. Do we want to go through each of them one by one and then go to the outputs? So if we go to the next one, which is did that switch?
Yeah, so now it's ranibizumab.
The comparator.
Yeah.
That's it. Oh yeah. So you now have the other two drugs that are here. So again, age range, gender, they are still exactly the same, but your target and your comparator concepts have now differed. So this is going to be slightly different to your first one. But again, it's the concept, the target concept, the comparator concept. You really want to make sure you have those ones in there correctly for this particular study. Then on your third one, your user inputs. Oh no, we're going straight to.
Sorry, I think we jumped to.
Yeah, I did. That was what happened. So it was a aflibercept versus ranibizumab, and then it goes to ranibizumab versus bevacizumab. Sorry about that. I clicked an extra time.
So for Cindy's study that we've got, there are 3 different drugs for blinding diseases, and we want to compare each one. So it's there's 3 analysis specifications that we'll be able to assess. So we'll be able to determine which databases are good for any of those 3 combinations of pairs.
Perfect.
And then, and this is for all of the study questions we're going to be evaluating.
Yeah, so this just gives you an idea, looking collectively at the 4 study questions, what you've got in there, what your inputs have been, and really it's a great idea to sort of see it from this perspective, because then you can actually see whether you've got everything in there that you want to actually put into those studies. And then we can then head over to the outputs from that perspective into the shiny.
Yeah, so just one thing I wanted to point out, you'll just see some of these differences here. It's like the age restrictions and then the study dates and desired visits. So just as a quick look, what these changes are. And then I want you guys to see my GIF. So let's go over to the output. All right. And are you good to share that, Sarah?
Yeah, should I go straight to the app?
Yeah, that sounds great.
Okay, so let me share my screen. Let's see.
See, the cool thing about Odyssey and everything that's going on, these packages are all developed, and there's going to be a nice, pretty shiny app that I don't even have to look at, or I can look at instead of Excel spreadsheets. Because I can tell you, when I saw the original output, I'm like, you want me to stare at these Excel spreadsheets? Holy smokes, I stare at enough Excel spreadsheets on a daily basis. So it's really cool that suddenly there's an app that I could utilize to look at this. So thank you, community, for building all this.
Big thanks to Jenna for sure.
Yeah, hugely.
And the rest of the community.
Exactly. Okay, so obviously you've run your package, you've got all your inputs in there, and then so you're going to, in your R environment, obviously call upon your Shiny app to actually produce something that will look very much like this. And so just to show you, this is essentially going to be your landing page. So as like any other of the Shiny apps, you've got your sort of table of contents, your introductions. There's lots of links to the various types and other pieces of information here. So do feel free to use those. But what you're going to do is here on the left-hand side, you're going to go to your data diagnostics. And you should see something like this. So we are going to take the first study, which is the VEGF. So here under analysis, this is where you've got a lovely drop down menu. You'll be able to choose the different analyses that is in here. So you need to select the ones that are specific to the VEGF one. So in this example, I need to scroll to, can I see it? Hang on, where's my, oh yeah, the first one's in there. Oh yeah, that's why I can't find it. Let me make my screen a bit bigger. That might help because I have it quite small. So you've got the A1. I'm going to call this drug A and drug B because I will just only hash the pronunciation. This is the first one for the VEGF study. Then you need to find the other two. So as I scroll, there is this one with ESRD outcome. And then the third one, which is this one. So what it's done is it's brought up a summary table essentially of sort of how each of the databases have performed against those three different analyses. So here you can see, hopefully you can see, there are the green zeros. So this essentially means that for these databases, so there's probably the first sort of half a dozen, I won't count them, where they are showing no flags. Essentially, there's no fails. Now, when I say fail, I'm obviously using that very sort of loosely. It doesn't mean that the data has failed. What it means is that for these data sets to actually perform well against your criteria of your study, then essentially it may or may not have some warnings. So if we look down from here, from the Clinical Center, as well as some of the IQVIA data sets that we have, you see some red figures. So you've got the ones over here, and then you've got for LPD Spain, Belgium LPD, there are 3 warnings for the first analyses. So it gives you a real high level of really sort of what are the good databases that really fit these study questions. But then it gives you a little bit of an insight as to potentially how the others are performing. So from here, you can now go into the drill down section. So up at the top next to the summary tab, if we go into drill down, now we've got our first analysis here. Obviously, you can come in and change those, but we can then look in more detail around what's really happening under the hood. So if we scroll down to say, what I'll do is I'll choose Spain, considering that it's one of IQVIA's databases and I come from IQVIA. I know a little bit about that one. So we click on view and hopefully this will work. Yes, excellent. They say don't work with children, animals, or live demos, but this is working, so excellent. So as you can see, this is a bit more of a detailed summary. You can see with the status column what's really passing the criteria and then what is failing. So here, so what I can remember from the summary, there are three main sort of warnings. One is around the comparator concept. So our drug B, our main concept, is essentially failing. Now, what that means that essentially this drug isn't found within this particular database. If I go to next, what I can also see is that our target concept, that also is not present within this particular database. And also there is an issue with the sample size. So obviously it's not big enough for this particular piece of analysis. But what this does is it helps you to really question the database that you're looking at. You're not necessarily going to always have the answers, but it will help you to go away and potentially question why. So, for example, I know a little bit about the Spain LPD data. So essentially, as these are sort of oncology drugs, you know, you'd expect to see them more in a secondary care environment. LPD Spain is actually a primary care setting. So the chances are that these drugs aren't actually recorded in a primary care setting in Spain. And that's something I could then go off and actually ask the data owners a bit more about. Maybe it's something to do with the time that drug was on a particular market and actually being on the market in that specific country. So it gives you a real great idea to sort of pose those questions and see really what's happening. So you can then start to explore all of the other ones as well and go through each of the different analyses. Are there any sort of immediate questions on that so far? I think we are good. So oh, go on, Mui.
Why the sample size? I mean, where did the threshold for the sample size come from? I think it's set at 1,000, right? Because I can see the one that's at the bottom here that you have failed.
Yeah, let me scroll down.
And it's failed because of the sample size, right? Sorry, it was the clinic.
This one, yeah.
Yes, that failed because of the sample size. Is there a reason why the threshold is at 1,000?
Yeah, so this is actually taken from some methods work that I think Martijn and Mark and Patrick have done, where they found that you need at least 1,000 people to be able to generate propensity score models. So you guys jump in if I mess that up. But that's my understanding is that the best fitting propensity score models are generated when we have at least 1,000 persons.
Yeah, both for estimation and prediction, when we're doing large scale models, it's helpful to have a sufficient sample to train your models. And that's what we're trying to do here. Of course, one can look at the numbers and just try to decide, but remember that those numbers that you're getting there are not actual sample sizes. They are this estimation based on what Claire said, having a series of independent observations. So if we look down at that data set from wherever that was, from Philip there,
yeah,
we don't know the actual number of patients, but we're guessing that it's somewhere between 37 and 190. And so given that that's the range that we're guessing the answer is in, one could reasonably say, well, if we're trying to do a causal inference study, trying to study the effects of these blinding disease drugs on end-stage renal disease, then no matter where the number is between 37 and 190, it's probably not enough for us to do the study. And so that's the general heuristic that you can follow when you're looking at these.
So really, to summarize what this tool really does for us is it allows us to initially look at high-level counts and high-level parameters to see whether or not a database is fit for use for my particular question. Did I get that right?
Mm-hmm. Yeah, that's exactly right. Mm-hmm. Yeah, like Patrick, just want to hammer it home. All of these are independent measures. We are not running cohorts. We are not looking at person level data. We are just trying to use aggregated summary statistics to generate some sort of estimate of what is available in your data, as well as what is the potential sample size. But we have not run any cohorts. And actually, one potential methods work we might do as we move on in the SOS challenge is to understand how well is this tool actually estimating the sample sizes once we actually start to run studies across these different databases.
Awesome. So like looking at this particular, I think it's an outcome here, right? So the Premier one doesn't, it has enough patients, it has the drugs, but it doesn't seem to have the longitudinality criteria that we need, right? So again, it's not that they can't choose to use it, but maybe they need to revisit and look at, potentially even look at your own longitudinal criteria. Maybe it's too long. So if you shorten it, maybe this will work for it, right?
I think Christian has a question.
Yeah. So actually, that's exactly what I am too. And we just talked.
Oh.
Apart from the fact that it's criterion, not criteria, I don't know why we have to continue getting that wrong. But did you at the beginning? I missed it. Is that? Can you set that, or is that like the sample size fixed?
Can you click on the view button there under the Premier one, Sarah?
Mm-hmm.
These were set, so you can see right there. It says 365 days.
I see.
We didn't show you how to set it.
Okay.
We went through a slide that shows you these are the parameters you can set. We didn't exactly walk through the steps to set this up, but it can be set.
Yeah, and on the website that Adam shared, there is detailed instructions on how to put together your settings for running data diagnostics and how to actually execute this R code.
So yes, you can set these up and change them. So that's the other thing I like about this, right? You can look at this and say, hey, Premier failed because the 365 is too long. Maybe I need to drop it to 180 and then run it again and see if that works. Because then I can reassess the criteria of all my entire cohort, not criterion, because that's one boss.
We'll fix it in the upcoming version. And one thing, so I did put it in the chat, but one thing we've talked about just for this initial proof of concept is that the database profiles we've talked about with all of those independent summary statistics, those are going to be held by the Odyssey Coordinating Center, and it will not be publicly available just yet. But what will be publicly available, and I've been talking, Evans and Jenna have been super helpful. We're actually going to have these data diagnostic results that you see here. Those are going to be publicly available, but we will not have the database profiles publicly available just yet. We'd like to figure out and understand how well this proof of concept works, how many data partners want to contribute, and any concerns you all have, and then we'll look to potentially make it public in the future.
Sarah, can you click on the other two cohorts that are, or outcomes that are part of this study? I just want to see what the results were. So for this outcome, if we scroll down, it seems very similar, right, to the first one. Well, probably because on the IQVIA data assets at the bottom, those drugs don't exist. And then the IQVIA data at the top, those are because the counts aren't high enough. But it seems like the same ones are passing or suitable. I shouldn't say passing, suitable.
And then that's the third one.
Cool.
Which is again very similar.
There's a question in the chat from Aki.
Yeah, so I was looking at that one. So essentially what we're doing is some very simple calculations to determine like min and max sample size. Basically, the maximum sample size is looking across all the criteria that you specify. What's the lowest number? Basically, what's the fewest number of people that meets an individual criterion. So if you have longitudinal and you have your target concept and your comparator concept, you see how many people, the fewest, not sure I'm explaining it well, but you basically find the fewest number of people that meet one of those criteria, and that's your max sample size you could ever get, if that makes sense. And then we do like Patrick said, if you're assuming they're all independent, if you multiply the percentages of people that meet all the criteria together, you'll get this min sample size. And that's what we're saying. It's a very generous estimate. We're going to try to understand how well this is estimating sample sizes as part of this exercise, but we're not doing anything very complicated here.
I know we only have a minute left, and I can see Thamir just scratching his table, wondering, Sarah, please click on his study so we can see if we can do our study of multiple sclerosis drugs and PML.
Oh, PML. Okay.
Yeah, Sarah, can you go by a summary just at PNL?
So we've seen that Cindy's study's a go, so that's very exciting. But Thamir is being selfish and saying, "What about my study?
There's only
be able to do that."
I think it's just
Let's give Thamir some good news too.
It's only 2, Sarah. We're good.
Yeah. Okay.
Yeah. So high level, looking at that, you got 1, 2, 3, 4, 5 database min that could be utilized immediately, right?
Mm-hmm.
But again, like we said, this is just a sample. This is not everything. It's just enough for us to get this tutorial and get you guys all excited about this.
And hopefully will be a good teaser so that you guys will want to share your own database with us, and we can get a much broader understanding and picture of the full Odyssey network from now and moving forward.
So our call for participation here is we ask all those who have data, please try to run this and participate in this study. And there is, like we said earlier, an office hour on Thursday at 10 a.m. And if you don't have questions, go there. Claire can help you with everything. And that's our call for participation, as well as our challenge to the community. We would love to see 100 to 200 of these databases where we can actually very quickly, just like this, see which one of those databases are quote unquote in estimation suitable for each of these studies.
Yep, and we're going to be sharing results in a secure way using the Odyssey SFTP server. So if you have your results, I bet someone out there ran it while we were talking. If you have your results, please reach out to myself or Lee or even Mui and Sarah, and we will send you the key file and instructions for how to share them in a secure way.
Yep, just like what we're showing you right now, this is not open to the public. This actually sits on, you can see at the end there, iqvia.com, sits on our server only, right? We did not take this anywhere else. It's all secure. And trust us, we want to make sure we're not putting anything out there that no one wants to see.
So this was excellent. Yeah. Oh, do you have more? Sorry.
No, I'm just saying next week we want to see 200 of these.
And for those who are wondering if we've got enough data to study fluoroquinolones in aortic aneurysms, or whether we have enough data to study psoriasis drugs, come to the call tonight at 7 p.m. Eastern time to get round 2 of the tutorial. You'll learn the same steps about how to run the procedure, but Mui and Sarah will go through the additional results so that we'll see the starting point of those additional studies.
Excellent. Well, thank you so much to Claire. Thank you to Claire and Mui and Sarah for this tutorial. Reminder, all the links that you need for the second tutorial, the office hours, they're all on the SOS homepage, which I just put in the chat. So please do check it out. This recording, you want to watch it again, any past recordings, they'll all be there. and all the key links for the 4 different studies. So so keep that homepage familiar. Thank you again to everybody. Hopefully the link, we'll send it out again for tonight's session right after this. So it'll be a reminder, goes out to everybody. So you should have that link there. Otherwise, we will see you next week or at office hours. Thanks again, everybody. Have a great week.